Hi doctor, my name is Nicholas and our group has 3 members including me, Rifki and Zhenli. We are using 3-bit D flip-flop to do a circuit to control a leaf system. So by using the 3-bit D flip-flop, it allows us to represent different states and transition within the elevator system efficiently. Okay, and this is our circuit which we have the clock disabler, 3-bit switches, password, 3-bit comparator, 3-bit counter, and the display status. Okay, I will talk about the clock disabler at the first time. We utilize a 5-input AND gate for the clock enabling. The clock is enabled when all the 5 inputs are set to 1. Okay, 5 of the input is start, power, clock, password, and comparator. And the start and power should always set to 1 so the leaf can work. Okay, so I will now talk about the comparator, which is the output of the comparator will be the input of clock disabler. And we use 3 XNOR gate here and 1 NAND gate. Each of the XNOR gate compare 1 bit of the input with the output, which is the current level, compared with the chosen level. So when 3 of these XNOR gate get the same input, so they will provide an output of 1 and go to the NAND gate, and 3 of the input of NAND gate is 1, and then it will get a 0 as an output. So that means if all the input and output is same, then it will provide an output of 0. So the leaf cannot be operated if the chosen level and current level is same. Okay, and you can see we have the choose level here, A0, A1, and A2. This is to get the input of the user, so he can choose the level he want to go. And also we have the current level here, display to the user. And as I said just now, the comparator will take the input from this choose level and current level to compare the values. For example, A0 is compared with Q0, and A1 is compared to Q1, and Q2 is also compared to Q2. Okay, and then we have the advanced feature that we designed, which is the password function here. This output of the password will also be one of the input of the clock disabler. We use a decoder here and we set the password to the 6 here. So when the user choose the correct password here, which is 0110 represent to 6 in the BCD, and then the user also need to close the door. And this enabler here, we assume that it is a door. So when 0 is the door open and 1 is the door closed. So when the door is closed, then this decoder will be function. So before you enter the password, you need to close the door, which is set this door to 1, and also to enter the correct password 0110, then the output from 6 will go to the clock disabler. If you enter the wrong password, it will not working, and no output will come out from this decoder. Okay, next we have the circuit here. This circuit is to find out the D0, D1, and D2 as the input of the D flip-flop. And we get this circuit by doing the CAMAP and the transition table, and that we will show in the report. And also we have the input X here. When the input X is 0, then it will count up, and when the input X is 1, then the leaf will count down. Next, we have the 3-bit counter here. We use 3 D flip-flop for the counter functionality, and we have the inputs for the D flip-flop. We have clock, D, preset, and clear as the input. And the clock is to initiate the counting, and D is to determine the count direction, and preset is to enable the counter operation, and clear is to clear the counter value. And the counter works only if the clock disabler output is 1 and preset and clear are set to 1. And the counter will count out when the input X is 0, and also the counter will count down when the input X is 1. After that, the preset and clear in the circuit is always need to set to 1 so that the counter can function properly. If not, the function will not operate. And also, we have another advanced feature here, which is the notification light. This notification light will light up when the user chosen level with the current level is same, or when the user reach his chosen level. In a nutshell, our elevator control system comprises 4 key components. The first one is the clock enabler, which allowing the clock to enable only when all the required signal, clock, start, power, comparator, and password are set to 1, and this ensures the control initiation of elevator movements. And second, we have the comparator, which employs the XNOR and AND gates to compare the user selected levels with the current level, serving as a crucial element for safe and accurate flow transitions, so that when the user enters the same level as the current level, the leaf cannot work. And also, we have the password section. It enhances the security by enabling password entry only when the door is closed. And using a decoder, password configuration becomes straightforward, and the system validates the correctness of the password before providing input to the clock enabler. And last, we have the 3-bit counter as a dynamic element to our system. It functions as a D flip-flop, counting up or down based on the user input when specific conditions are met, which is the input X is 0, then the counter will count up, and the input X is 1, the counter will count down. And this contributing to the overall versatility of our elevator control. That's all for the explanation to our system controller. Thank you.